So you have notes that you can write things down. Last time we left off here, so we were working with figuring out what a cation is and what an anion is. So whenever you see this word ion, okay, you might think, oh, onion? Yeah, no, an ion. That means a charged particle. Are we ready?
Yes.
Great. So our most recent example was trying to figure out the Bohr model diagram for calcium. Okay, and so we first looked up the atomic number, which was 20. That tells us how many protons or how many electrons we have. Same thing over here with oxygen. Says how many protons or electrons we have. Okay, in calcium we had 20. You can only fit 2 in the first orbital. Okay, sometimes they call them orbitals. Sometimes they call them electron shells. Same thing. Okay, so let's label that. How about orbitals or electron shells? Okay, that's where the electrons live according to the Bohr model. Okay, so we have this picture, we're just adding to it. Okay, and you're like, well, what's that compared to? So the difference would be the Rutherford model, right? That's our typical science picture, right? It's beakers and microscopes and lab safety glasses. Okay, and usually this model of the atom. Okay, that's the Rutherford model of the atom that has protons and neutrons in the center, and it does have electrons floating around the outside, okay, but not in specific shells. Okay, so the guy who came up with that one was Rutherford. Okay, section 2 has more about the scientists and the atomic models. Yes, dear?
Is it okay if I get my notebook? Because my notes are in the back.
Sure, it's, can I get it for you in a second?
Okay.
So with calcium, we had 2 in the first shell, 8 in the second shell, 8 more in the third shell, and we still had 2 left. Okay, so those were called valence electrons. Valence meaning they're on the outside shell. Okay, valence electrons. Okay. When we drew oxygen, we had 8 electrons. Okay, so we put 2 in the first shell. 8 minus 2 is 6, so we had 6 left. So 6 goes in the next shell. Our elements like to have a full octet to be stable. Okay, so we want a full octet. Okay, oct meaning 8. So we want 8 electrons in our outermost shell if we can. So what oxygen will do, if it has a chance, it will steal the electrons from calcium. So if I'm taking away negativity, right, you're in a bad mood and I took your negativity away, you're feeling more positive. Okay, so the ones who lost electrons are positively charged. These are called cations. Okay, like a cat. Meow. This little scratch sound. Okay, and that's what we were actually able to see. If you look at your periodic table, now you see that the charge, that's what it's for. It's showing the ionic charge. Okay, and so calcium has 2 valence electrons to give away, and our anion in this case is oxygen. It steals 2 electrons. Okay, so that has a 2 minus charge. So to name this compound, okay, we'll erase some of this here so we have room. Okay, we have calcium with the 2 plus charge and oxygen with the 2 minus charge. We want them to be balanced, to have no charge. So does plus 2 minus 2 equal 0? Yes or no? Yes. Okay, so we're good. Those balance. So we only need 1 of each. And with calcium and oxygen, We just don't write the 1, right? It's like invisible. Right, so we don't write that down. So our molecular formula is CaO, because we have one of those and one of those. So what would this be in written form? Like, what's its molecular or ionic name? Calcium oxide. Okay, so with molecular naming, we would be using the prefixes. So this would, if we were naming it with the molecular rules, this would be calcium monoxide. Okay, but we're not because it's ionic. How do we know it's ionic? Because it's made of a green one and an orange one, right? A metal and a non-metal. So put your finger on your periodic table where calcium is.
Yeah.
Okay, put your finger on oxygen on the periodic table.
Yeah.
Okay, so one is green and one is orange, right? One's a metal, one's a non-metal. So those are ionic. If it's two non-metals, two orange ones, then it's molecular. Okay, and you use the rules with the prefixes. Okay, let's do another example. Okay, without the orbitals this time, we'll just do this piece.
Okay.
Okay, let's take hydrogen and fluorine. Okay, what's the charge? Let's put examples. Okay, example 1. What is the charge from your periodic table on hydrogen? 1. Okay, is it positive or negative?
Positive.
Positive. What is the charge on fluorine?
1.
1.
Negative.
Okay, so I have 1 positive and 1 negative. Does that balance to 0, yes or no? Yes. Okay, so I just need 1 hydrogen and 1 fluorine, but again, we don't write it. Okay, so that's how you say hydrogen fluoride. Okay, so this is the name. That is the formula. Let's do an example where the numbers are different. Yes? Yeah. Okay, let's take, I don't know, magnesium. And what else we got here? I need a non-metal.
Beryllium.
That's a metal. I need a non-metal.
Argon.
Argon? That one doesn't react because it's in the noble gases group. Iodine, sure. We'll do iodine. Okay, what's the charge on magnesium?
2. Positive 2.
Yeah. Okay, positive 2. What's the charge on iodine?
-1.
Negative 1. Okay. Does that balance, yes or no? No. What can I do to make it balance? More of which one?
Magnesium.
I need another negative one to balance out the positive. Okay, so I'm going to add another iodine.
Yes.
Okay, so 2 and 2, we're good. So I can write my formula now. How many magnesium?
2.
Okay, how many actual atoms though?
Oh.
Only 1. How many iodines? 2. Okay, so what would the name of this be?
Magnesium. Iodide.
Iodide. That's right. Okay, magnesium iodide. Let's do a couple more examples, and then I'll see if you notice a bit of a pattern, okay, to do the swap and drop. Okay, let's take something with nitrogen and lithium. Okay, what's the charge on lithium?
Positive 4.
Okay, what's the charge on nitrogen? Oh, there's 2. Okay, when in doubt, pick the top one. Okay, what's the nitrogen? Yeah. Okay, it has a 3- charge. How do I get that balance? I have 3 electrons that were stolen.
Yes.
So how many of these do I need?
2 more.
2 more.
2 more.
Okay, so how many lithiums do I have altogether?
3.
3. How many nitrogens do I have altogether? Okay, I only have 1 atom of nitrogen. Okay, but I don't write it. Okay, let's also put the name of it. Okay, what's this called?
Lithium nitride.
Lithium nitride, yeah. Okay, I'm going to give you an example with words, and you put it into a formula. Okay, let's put this one. No, not that one. Okay, so start by figuring out what the symbols are for iron and bromine. Okay, we'll just give our classmates a minute to think. Okay. What's the symbol for iron? Okay, now on your periodic table, what does it say the charges are? What are the choices? Yeah. Okay, so that's what this is for, is it tells you which one to choose. Okay, so this is 3 in Roman numerals, so like in Roman numerals that's 1 is an I, 2 is 2 I's, 3 is 3. Does anybody know 4?
I and then V.
Yeah. IV. 5 is just a V. Okay, so those are the Roman numerals. So that tells you which one to use. So let's use the 3 positive one. Okay, and bromine is what letters? Okay, and the charge? Okay, so how many of these do I need? 1. How many of these do I need? 3. Okay, because I'm going to give away 3 electrons, so I need this guy to take 3 electrons. Fe1, Br3. Okay, so what's it called? Oh, we already had that. Okay, it's called iron 3 bromide. Is anybody noticing a pattern with how the numbers work?
Yes.
Yes, what are you noticing?
It either goes up or down.
It goes up or down, yes. Okay, and other people sometimes notice, oh, can you just swap them sides and bring them down? Yeah. Okay, we call it swap and drop. So if you take the charge off, let's do the shortcut in red. Okay, shortcut. That says UT. Okay, and let's call it the swap and drop. Okay, so magnesium with the 2 plus charge and iodine with the 1 minus charge, you can switch them places and bring them down. So this is called superscript, and then subscript is when you write them down low like this. Okay, so you crisscross them like this. Magnesium would only have 1, and iodine would have 2. Is that the same as what we had? Yes. Okay, but we don't need to do this step. Okay, we can do the shortcut. We can do the cheat. Okay, let's do that on this side. Yeah, it's easier. Okay, but people sometimes like to know why. We have a certain number of atoms in a compound. Okay, and this is the Y. Right, so let's go back to here and do the shortcut. Okay, Li 1 positive. Nitrogen has 3 negative charge. Yeah, crisscross applesauce. I like that. Okay, so lithium. Okay, we're going to need 3 and just 1 nitrogen. Is that the same as when we figured it out this way? Yes, it is. Okay, so let's do the last one just because we should. Okay, swap and drop. So 1 of those and 3 of those. Same as this. Hooray.